Well, good morning, everybody. Today's lesson, we're continuing with trigonometry, and we are going to deal with what's called angles of elevation or depression. As you might guess, elevation means you're going up, depression means you're going downward. And what I'd like you to notice that it's always in relationship to a horizontal line, okay? So for instance, let's look at angle 1 here. Pretend that you are in there and you are, oh, that's interesting. I didn't know I could do that. Well, never mind. All right. So pretend you're in there and you're looking out this way. Again, let's pretend you are here and you're looking out and down at the ship. So is that angle going down or is it going up? Well, I think you can see it's going down in relation to that horizontal. And that's why we call that an angle of depression. On the other hand, let's pretend you are inside angle 2 and you're looking up at the birds. You're going upward. That's an angle of elevation. So similarly, angle 3, you're here looking down at the sub, that's depression. Or if you're in the sub looking up, again, in relation to a horizontal, if you're looking up at the ship from underwater, that's elevation. Again, the trick is to always put yourself in the vertex of the angle and look out that way. So here you are in the airplane, you're looking out at this guy. So you're looking down, that's an angle of depression. If you're this guy looking up, that's elevation. If you're looking down, 7 is depression. And if you're in the boat and you're looking up at the sky, that's an angle of elevation. All right, that hopefully is pretty straightforward. Now, on your notes, and what I want you to do is I want you to, hopefully you can print out these notes, and I want to see all the work, all the steps, and then take a photo of it, upload it, submit it through Canvas. Now, I can't write on this board to my frustration, but what I've done is on separate paper, I've drawn this situation. So let's look at number 9. Here you've got this kid with a kite, and we're trying to find out how far it is from here, that if you drew a perpendicular line from the kite down here, how far is, what is that distance here? Well, here we've got the same situation. I didn't draw the little guy here. Oops. So here's the little guy. Now, as you might guess, we're dealing with trigonometry now. And I'm going to make sure my camera is centered here. I guess that's centered. Okay, so what trig function deals with, hopefully you can recognize that this is an adjacent side. That's the hypotenuse. So what trig function deals with adjacent over hypotenuse? Hopefully you're remembering that's cosine. So we're going to take the cosine of 40 degrees equals the adjacent over the hypotenuse, and then we're going to multiply both sides by 125, and that will give us the length. All right, so let's go to our calculator, calculate 84, I believe it's called. And let me find mine, there it is. Now, once more, we're dealing with trig, so you've got to go to the mode function and change it to degree mode. So I'm going to do that right now. Go to mode. Sure enough, the default is radian. I'm going to right arrow over to where it says degree and then hit enter. Okay. Now I can go back, go second quit. All right, so I want to do 125 times the cosine of 40. So 125 cosine of 40, hit enter, and I get 124.7 feet, or whatever the units were. 124.7. And that's how far it is from here. Okay, let's go back to the worksheet for a second. Here you've got a building. We're trying to find how high the building is. We're 300 feet away from it, looking up. That's an angle of elevation of 30 degrees. So let's go back here. Now, what trig function gives us an opposite and an adjacent side? Okay, here again, we've got an opposite, adjacent, forgot my right angle there, that's the hypotenuse, so opposite over adjacent, that's going to be tangent. So we're going to say tangent 30 degrees is equal to opposite over adjacent. And so, as we've been doing, we'll multiply both sides by 300. And that'll give us that length of the side. So I'm going to do 300 tangent. You don't have to put the time sign. It does it automatically. Tangent 30 degrees, close parenthesis, hit enter. 173.2 feet tall. Okie dokie. So that's 9 and 10. Now let's let me see what I forget the next one I did. Okay, number 13. All right, so let's go back to our sheet here. Y'all are going to do 11 and 12. All right, so let's read this together. We got a person standing 40 feet from a flagpole. He can see the top of the flagpole at a 35-degree angle of elevation. All right, so let's draw that in. 35-degree angle of elevation, but it's from his eyeball, and that'll come in. That'll be important in a minute. Well, I missed. Let's pretend it went up there. Now the 35 degrees? Yeah, 35 degrees is right here. Again, in relation to that horizontal, this will make it the right angle. And this person is 4 feet off the ground, if I remember right. Let's check it out. Eye level is 4 feet off the ground. So what's the height of the flagpole? All right, so we need to find the whole height, but what we're going to do first is we're going to find this height here, and then we're going to add 4 feet to it, because the angle is starting 4 feet off the ground. All right, so let's just look at this triangle here. What do we have by way of sides? Well, what would we call this side? That would be an adjacent side, correct? And that's an opposite side. So what trig function does opposite over adjacent? Well, once again, we're dealing with tangent. So we'll say the tangent of 35 degrees is equal to the opposite over the adjacent. Multiply both sides by 40. And let me get my calculator here. So I'm going to do 40 times tangent 35, hit enter. Okay, so x is equal to approximately 28 feet. But we don't want to get in a hurry because we need to add that 4 feet to it as well. So the flagpole, I'll call that F, is 32 feet high. Okie dokie. All right, let's see what I got next. Oh yeah, I like this problem. This is kind of fun. All right, here we've got an eagle perched 40 feet up in a tree. Okay, there's the eagle. Y'all need to sketch this out, so feel free to pause the video. He's 40 feet up in a tree. Good looking tree, isn't it? Now this example talks about a vole. Well, a vole is like a mole, but I made it a cat. So he looks down at a 35-degree angle. And we need to find out how far is the eagle to, in this case, the cat. So I want to know what this distance is right there. I'll call that x. Now, here is the tricky part. Notice that it said he looks down at a 35-degree angle. So we're talking about an angle of depression here. Most students are going to say, oh, that must be right here. And they would be wrong. That's not the 35-degree angle that you're looking down at. Remember, these angles are always in relation to a horizontal. This is the 35-degree angle right there. So, and we've got a right angle here. So what do we got? We got this 35-degree angle that there's no sides other than this one. What do we do? Well, these lines are parallel, and I hope you can remember alternate interior angles. So that this is 35, that one is 35. Aha! So now what do we got? Now we have an opposite, and we have a hypotenuse. So what trig function is that? Opposite over hypotenuse. That would be sine, would it not? All right, so we're going to say that the sine of 35 degrees is equal to opposite over hypotenuse. Now in this case, we've got to multiply both sides by x. Then we divide both sides by the sine of 35 to clear that out. And so when we're done, the length from the eagle to the cat is 40 divided by sine 35. So let's do it. 40 divided by sine 35. And I got 69.7 feet till he eats the cat. Okay, so I want you to do everything on this worksheet. Show all the steps, take a photo, submit it, and we'll be good to go. Y'all have a good one. Bye-bye.